Alright, in Chapter 8 we're going to look at conic sections, and specifically in 8.1 we're going to look at parabolas. So just to start off here, conic sections are a cross-section of a cone. And to be more specific about what a cross-section of a cone is, it's where we intersect a plane, in this case with a right circular cone. And so down here we've got examples of how that works, and if you print off the PDF of this, unfortunately part of the image isn't that great. Sorry about that, but this is what it should look like. So if you look at this first one, the light blue is the plane that we're cutting through, basically the bottom part of this cone, and you can see that this shape is a parabola, which we're already definitely familiar with from this year. And then on this second one, it actually has two planes. This one that is kind of off kilter is showing us an ellipse. This one that looks more like it's parallel with the bottom of our cone, that's a circle. And all of our circles, we're going to call them ellipses in this section, because all of the same rules apply to both of them, basically. And then the reason there's two cones stacked on top of each other for each of these is because of a hyperbola. If we cut through the top and bottom cone, right here we end up with a hyperbola. And you did these last year in Algebra 2, so you should be a little bit familiar with them, but it's okay if you don't remember everything from last year. So to start off, we're going to talk about just parabolas in this section. So the definition of a parabola is the set of all points in a plane equidistant from a particular line called the directrix and a particular point called the focus in the plane. So I have here a parabola that's drawn with all of the parts labeled that, well, actually most of the parts labeled that we're going to find important. And so the part that's our parabola is actually this U-shaped part. At the bottom of it, a point we're already familiar with from this year is the vertex. That's the very bottom of our graph. And so what this definition is saying is that if I look at a point on my parabola and I draw a line that's perpendicular down to my directrix, that line should be the same length as the line that it takes to get to my focus. And there's some pretty cool applets on the web that let you move a point back and forth and see that really is true. So that's what the focus and the directrix are. And we're going to look at all kinds of parabolas and their foci and their directrixes and all of that stuff. Alright, let's look at some things that we can do with parabolas. So we're going to start off looking at parabolas with the vertex at the origin, 0, 0. And so notice that our standard equation here is actually solved for the variable that's squared and not for the variable that's not squared. So that is important, that's the standard equation. The reason we do that is because then whatever's in front of the variable that's not squared equals 4p. And p is this number that is our focal length. It's the length between our vertex and our focus, and that allows us to write things like our focus, our directrix. It also tells us about our focal width. So that p is very important for us for finding our problems. And there's kind of a pattern that happens. I like to look at this and say, okay, y on this first column of stuff, we have y, which is not squared. If we know what p is, then we change the y value of our vertex to p, and then we also can say, well, y equals negative of our p. And so the connection there is that we have y, which is not squared. It changes our y value here, and it gives us y equals. And so we can kind of, remember or use that to help us remember what we change based on whether it's y not being squared or x not being squared. So on the second one, x is the one that's not squared, which means that the p goes in the x spot. Our directrix is x equals something. So that's really helpful. So let's do example 1. Find the focus, directrix, and the focal width of each parabola. So what I care about on both of these is if the standard equation, for example on this one, is x squared equals 4py, then that means that 8 equals 4p, which means p equals 2. Now I'll be able to go in and fill in the focus directrix and the focal width. The focus, since this is x squared equals 8y, y is not squared, is going to be 0, 2. The directrix is going to be y equals negative p, which is y equals negative 2. The focal width, actually, we just have to look back at what this is, take the absolute value of it, and that gives us a focal width of 8. On this next one, this one over here on the right, it's not actually in standard form. Our standard form would be y squared equals 4px. That's not what we have. So to get the y squared by itself, we need to multiply each side by a negative 6. So that will give us y squared equals negative 6x. That means that 4p equals negative 6. So p equals negative 6 divided by 4, which will be negative 3/2. Okay, so it's a little unpleasant because that's a fraction, but we'll see it through. The focus, since x is the variable not squared, is going to be negative 3/2, 0. The directrix is going to be x equals negative p, which means x equals positive 3/2. And the focal width is what was originally in front of the x, but the absolute value of that, so that's just 6. Now let's look at parabolas where the vertex is not at 0, 0, it's at some random point hk. A lot of this is going to look similar, it's just that instead of having 0, 0, we have an actual point. So we are basically moving our graph different directions. So for our standard equation, next to x, we're going to put in the x value for our vertex, which is h. Next to y, we're going to put in our y value for our vertex, which is k. And notice that it's a minus h and a minus k. So it's going to end up switching the signs of whatever our vertex is. So if we look at this first one, this is still the situation where y is the variable that's not squared, which means it opens up or down. For our focus, we start off with the vertex and we add our p to the y value, because y is what's not squared. We add it to the y value. Our directrix, we subtract from our y value. Our axis of symmetry here is going to be x equals our whatever our h value is, and our focal length and focal width stay the same as what they were. On the second one here, x is what's not squared, and so that means it opens right or left. For my focus, I'm going to add p to h because I'm changing my x value. On my directrix, I'm going to subtract my p from h, and then my axis of symmetry is going to be y equals k, which is the y value of my vertex. The focal length and focal width are the same as what they were. So let's again find the focus, directrix, and the focal width of each parabola. And actually the first thing we need to do is find the vertex. So this problem, this first problem on the left, looks like the second column, okay, where x is the variable that's not squared. And so our vertex, the value attached to y is 2. Well, it's negative 2, but we'd switch it to positive 2. The value attached to x is 5, so we switch it to negative 5. So our vertex, which is going to come in handy here, is negative 5, 2. The other thing we need to know is what our p is. And so this is in standard form. That means that 4p equals 3. So p equals 3/4. So for our focus, we're going to take the vertex, and since x is the variable not squared, I'm going to add 3/4 to the x value of my vertex. So this is what it's going to look like, negative 5 plus 3/4, 2. Well, I can figure out what that is by getting a common denominator or plugging in my calculator, whatever. That looks like negative 17 over 4 to me, 2. So that's our focus. Our directrix, since x is the variable that isn't being squared, is going to be x equals, and we're going to do our h minus p, so negative 5 minus 3/4, which means x equals That's negative 20 over 4 minus 3 over 4 is negative 23 over 4. And then our focal width is simply whatever was in front of the parentheses that had x, which is 3. So fractions aren't particularly pleasant, but we can still do it. On the second one here, the right side, this is not in standard form, so we're going to multiply both sides of our equation by a negative 4. Now notice when we multiply the right side by negative 4, we need to put that into parentheses, and so that's going to give us x plus 4 squared equals negative 4 times y plus 1. So I need to first look at what the vertex would be. It would be negative 4 comma negative 1, because the 4 is attached to x, the 1 is attached to y. And so my focus, since y is the variable that's not being squared, I'm going to say is negative 4 comma negative 1 plus p. Oh, we haven't found p yet. 4p equals negative 4, so p is negative 1. So negative 1 plus a negative 1 is what we're doing for our focus. So that's going to give us negative 4 comma negative 2 for our focus. Our directrix, since we're changing y here, is going to be our negative 1 minus a negative 1, so that's really plus 1. I didn't mean to put that parentheses there. So that means that y equals 0 for this one. The focal width is the absolute value of what was in front of our parentheses with y, so our focal width is 4. So the other main thing they're going to have us do in this section is find an equation in standard form for the parabola that satisfies the given conditions. And so there's a lot of different things they could give us, and we'll basically want to be looking back at those charts to help us. But what we really care about is that we know what the vertex is and that we know what p is, and that's going to help us figure out the equation for a parabola. So this first one, it says vertex 0, 0, focus negative 3 comma 0. So we're going to be looking at the chart that has vertex at 0, 0. The focus is negative 3 comma 0. That means that my x is what changed, and so that means that I have y squared equals 4px. Okay, because what changed here? The x. So that means that I have x as the term that's not squared. The p in this case is going to be negative 3, because look at what it says for focus. If my vertex is 0, 0, it's p comma 0, so that means that p has to be negative 3. So that means my actual equation is y squared equals negative 12x. For the second one, focus 0, negative 4, directrix y equals 4. So because this is negative 4 and this is positive 4, we do know that our vertex is at 0, 0. So we can use that first chart. And we also know that since the y value is what we're talking about here, that this value is what's not 0, and we have y equals here, that means that y is the variable that's going to be not squared. So this is going to be our standard form. And then our p is simply going to be this negative 4 right here that's in our focus. So this is going to be x squared equals negative 16y. Next, this is the last of the ones where our vertex are at 0, 0. It says it opens downward and the focal width is 6. Opens downward means that it has to be x squared equals 4py. It also means that this number in front of y has to be negative. That's the only way to open downward. If it said opens upward, we would know it had to be positive. The focal width, if we look at our chart, is the absolute value of 4p. And so we don't actually need to find 4p here because 4p is what we want. What it means though, since the focal width equals the absolute value of it is that we are okay to just put a negative in front of that 6 because it opens downward. It has to have a negative there. And my focal width would have been the absolute value of -6. So that would be my answer. Now on these next three, our equations are not, our vertex is not 0, 0. So in this first one, it tells us our vertex is -5, 6. It tells us our focus is 3. So look at what's changed. It's our y value, which means that my standard form is going to look like this. So we know the h and the k because we know our vertex. We need to figure out what p is. And p comes from, if we know our focus, our p is h comma k plus p. But 3 is what k plus p is. And we know that k is 6, which means that p is -3. Okay, and you could have gotten there faster than that, most likely. But p is -3, so now we can fill in this equation that this is going to be x minus, well, minus a -5, so x plus 5 squared equals 4 times -3 is -12, and then that's going to be y minus 6. Next, they don't tell us our vertex. We're going to have to figure out what our vertex is. This one is, in my opinion, the trickiest of them, where they tell us the focus and the directrix. Since our directrix is y equals, we know that we're looking at the case where my y is not squared. Just from that chart. And then I need to know what my vertex is. I need to know what p is. Now, I don't know either of those things right now. I know that my focus, which is 3, 4, is going to be, since it's y equals 1, my focus is going to be h, k plus p. So we actually do know the h value for our vertex. Our directrix, which is y equals 1, in our chart we have y equals k minus p. So what we have here is that 4 equals k plus p and 1 equals k minus p. So I believe we can solve that because that's a system of equations. That's going to give us 5 equals 2k, so k equals 5/2. Okay, that means I can plug in 5/2 back into my system of equations. I can say 4 equals 5/2 plus p. So I subtract over 5/2 and get 3/2 for p. So I can fill all of this in to my equation, and I should get x minus h, which is 3, equals 3/2 times 4 would give us 6, and y minus k, so y minus 5/2. And the last one, they tell us the vertex, they tell us it opens left, and the focal width is 10. And so since it opens to the left, that means that x is the variable that's not squared, and that it's going to have a negative in front. It's going to be y plus 4 squared equals 4p is the same as 10, but since it opens to the left, which is towards the negative numbers for x, it's going to be -10. And this will be x plus 1. So there's that one. Let's look at sketching the graph of the parabola by hand. And so what is going to matter for us to be able to find all of these things I have listed is we're going to need to find p. So 4p equals -16, because 4p equals whatever's in front of that set of parentheses. So that means that p equals -4. And so I can say what the vertex is. The vertex comes from this number and this number. It's going to be -3, -2. the focus, now that I know what P is, since X is the variable not squared, it's the one that changes from our vertex. It's going to be -3 plus P, which is -4. So that's going to be -7, comma -2. The directrix, since X is a variable not squared, is going to be X equals -3 minus -4. So that's like -3 plus 4, so X equals 1. Our axis is Y equals whatever the Y in our vertex is, and the focal width is the absolute value of what we had in front of our X plus 3, so our focal width is going to be 16. So this graph is going to be kind of big. Alright, our vertex is at -3, -2. So we can draw that really easily. That's where our vertex is. Our focus is going to be at -7, -2. So we were at -3, -4, -5, -6, -7. Right, here's our focus. Our focus, by the way, is always going to be a point that's inside of our parabola. Like the direction that it opens, it'll be that direction from the vertex. The directrix is going to be the line X equals 1. So let's draw that as a dotted line. That's the directrix. Then I have my axis, which is Y equals -2. It goes through my 2 points here. It's like the axis of symmetry. And then the only other thing I really have here is focal width. My focal width is 16. So at my focus, it's going to be 8 below and 8 above is how far my parabola is going to go, which is how this ends up being a really big graph. So 1, 2, 3, 4, 5, 6, 7, 8. Like where my focus is, I'd go down 8 and up 8. That's how wide my graph is, 16 wide at my focus. So when I draw this, it's going to be a U-shaped graph that goes through the vertex and the focal, what I got for my focal width. Let me try this again. Something like this. Obviously it doesn't have to be perfect. Now if we were trying to graph this in our calculator, notice that we would have to solve for this y up here, which would require us square rooting both sides. And remember, when you take the square root in an equation, you have to put a plus or minus sign. So keep that in mind, and you might try doing that on this problem. Okay, the last example that we're going to look at is prove that the graph of the equation is a parabola and find its vertex, focus, and directrix. What this is really asking us to do is complete the square on this problem to make it look like one of the standard equations that we have. So let's talk about how to complete the square on this so that it'll look the way we want it to. We're going to isolate the terms where we have a squared variable and a not squared variable, and so that means that we're going to have to add y and subtract 3 over to the other side. So this is going to be x squared plus 2x. I'm going to leave a blank here, and then y minus 3. And then I'm going to put a blank over here, because when we complete the square, I'm trying to figure out what do I put in this first blank so that I can factor this left side into something squared. So to figure that out, we take this number in front of x, which is 2, we divide it by 2, because that's what we do, we always divide it by 2, then we square it so that we get 1. So I'm going to add 1 right here, which means I also have to add 1 on the other side to keep my equation balanced. So this left side is going to factor into x plus 1, x plus 1 squared. On the right side, we have negative 3 plus 1, which gives us negative 2. This is going to be y minus 2. So we almost have what looks like standard form, but normally we have a parentheses right here and a number on the outside. Well, in this case, there isn't a number in front of y, so we'd make it be a 1 in front. And that right there is the standard equation of this parabola. Then we would find its vertex, focus, and directrix. So the vertex would be negative 1, 2. The focus, we have to know the value for p. So 1 is what's in front of that parentheses. 1 equals 4p means that p equals 1/4. Since y is the variable that isn't squared, we would do negative 1, comma, 2 plus 1/4, which is negative 1, comma, 9/4. And for our directrix, it's going to be y equals, so it should be y equals 2 minus 1/4, which is 7/4. Y equals 7/4.